Okay, for people who just joined, we'll get started in a couple of minutes. Okay, so we let's wait for a couple more minutes to get see if any other people join. Okay, I am going to get started. Let me turn on my video. Okay, so good afternoon, everyone, and welcome to TGIP, a new format that we have in 2021. Is like monthly project update every second Wednesday, like 12 p.m. Pacific time. And it has been a while since we do TGIP last year, and we continue kind of hear a bunch of the feedback from the community that TGIP provide very useful information for people to learn about the progress. And we hope like the new format, we want to kind of make the new format more interactive and be able to provide useful information for people that who are exploring Pulsar or looking into using Pulsar and looking into using new features that introduced in Pulsar project, as well as in the entire ecosystem, like not just Pulsar, but as well as a lot of components that are integrate with Pulsar, like Kafka on Pulsar, Pulsar Flink integration, and new connectors. So we hope the monthly project update will share enough useful information for people to learn more about Pulsar and be able to kind of use all the new features coming out from Pulsar. And so if you just joined the webinar, and if you have any questions, feel free to submit those questions through the Q&A panel, and I'm happy to answer those questions all the way around with this webinar. If I didn't get a chance to answer your question, we will make sure we follow up after this call. So let's get started with a full presentation about monthly project updates from on February 2021. And let's get started with the core Pulsar. And the last major release that we have made is Pulsar 2.7.0 release. And it was released around late December. So it probably just like a month away. But there's a lot of very useful feature, very awesome features were introduced in 2.7.0. So I'm listing out those kind of major features here for you to kind of have a high-level idea about those features. And I'm going to dive into individual ones to give you a very high-level idea about what are the features and how you can use them, and what is the current status of those features. Is it production ready, developer preview, so you can have a better idea like when you want to take these features to your production. So the first one, I think one of the most exciting features in Pulsar 2.7.0 is Pulsar transaction. And it was released as a developer preview. As a developer preview feature, that means all the functionality is already in place. And we call it developer preview is there are still a fair amount of time for us to do the integration test, load test, chaos test to stabilize this feature. So what Pulsar transaction is doing is for people who are new to Pulsar, is Pulsar provide at least once processing guarantee via besides at least once processing guarantee, it also provide a mechanism called master deduplication to ensure exactly once production. So that means for people who want to produce the messages to one single topic or one single topic partition, it's able to use the exactly one producer to produce the messages in exactly once, but it only guarantee so it only apply to single topic. It doesn't apply to multiple topic, or you want to cross across different topic or across different topic partitions. So the existence of the introduction of Pulsar transaction want to solve the problem. It want to simplify the developer to developing an exactly once application. So you don't need to worry about what would be like how I need to handle duplications, how I need to kind of write my code to ensure I process the mastery exactly once. And the feature, like to enable this feature, I think it's very simple. What you need to do is you first to enable component within broker, which is called transaction coordinator. So you have to set configure your broker configuration to enable to set transaction coordinator enable to be true. So then you have a transaction coordinator running along with your broker. And to provide a bit more color about transaction coordinator is this component is running across different brokers, and it's used for coordinating different components within different brokers within a same Pulsar clusters on committing or aborting single transaction. And it's the role to make sure like either all the update all the production or all the acknowledgement to topics within one transaction either success as a whole or they are abort, so that you don't see partial success from a transaction. And once you enable the transaction coordinator, the next thing is you need to initialize the transaction coordinator metadata. So for people who are creating a new cluster, this command is already built in the initialized class metadata. So you don't need to run additional job in order to kind of initialize the transaction coordinator metadata. But if you already have a Pulsar cluster running and you want to enable transaction coordinator, then you need to run additional command to initialize the transaction coordinator metadata. So once the metadata is initialized, then all the transaction functionality are enabled on your Pulsar cluster. That is the changes what you need to do in the broker side. In the client side, I think it's very easy, and I have to call out right now is the transaction is only support in for Java client. It does we haven't provided support for other language yet, but there would be a couple of release that will take the transaction features and enable them for all the different language clients that we have. So for Java client, if you want to enable transactions, the only thing you need to do is in the Pulsar builder, you set enable transaction to be true. So then once you set this enable transaction, then you are able to use all the transaction API to like produce and consume messages within a transaction. So that's the changes that you need to make. Before kind of you write your code using transaction. So is it transaction introduce? Does transaction introduce new set of API? Yes, it does, but it's also tightly integrated with existing producer and the consumer API. So this is an example to show how you can use the transaction feature. First of all, you need to use the Pulsar client to open a transaction. And along with when you open a transaction, you want to specify a transaction timeout. Transaction timeout means that if your client is not able to commit a transaction within that given timeout, then the transaction coordinator within Pulsar cluster would abort that transaction. And that is useful because sometimes when you write an application, you open a transaction, the application might crash, then it didn't get a chance to like commit or abort a transaction. So you want the system to automatically clean up those outstanding transactions. So once you have the transaction available, the next step is you want to publish a message within that transaction. So what you need to do is, it's very similar as the normal like publish process. Is you just new a message and specify the value and call send. Then you're sending a messages. And it's a bit different here. Is you just need specify the transaction when you new a message. So that means this message would be published as part of this transaction. And then you want to acknowledge the message that you just received. And very similarly, you just, it's a normal process. You call consumer.receive to get a message. But when you want to acknowledge the message, you just put the transaction as part of your acknowledgement call. So that would tell Pulsar client that I want to acknowledge this message as part of this transaction. So in this example, what the transaction does is it will produce a new message and acknowledge another message that it received, and those two actions would happen in an atomic way. So either both the message so the message will be produced, and as well as the other message will be marked as acknowledged, or both of them would fail. Like the message is not produced and the acknowledgement also failed. So you would still able to receive the message again and process this message and produce a new message again. It would ensure there's no duplication that would happen like when a transaction fail. And once you kind of prepare all the actions that you need to do within a transaction, then you can call transaction.commit, then this would commit the transaction. And it's very simple. It doesn't change your existing logic. And the transaction API is also fit very well into existing Pulsar API. So you can have multiple transactions happening concurrently. You don't need to worry about like in some other kind of the messaging system, you can only have one outstanding transaction, which would definitely slow down the whole throughput. But Pulsar is kind of taking a bit a different approach. Is it ensure you can have multiple concurrent transaction to kind of max out the entire throughput, even you even you are using transaction. So there will be no throughput difference between like using transaction versus non-transaction mode. So this is the Pulsar transaction, and it's a developer preview feature. And if you are interested in trying out those features, you can please try it out and give us feedback. And this feature is planned for GA in the upcoming 2.8 release. And 2.8 release would be coming probably end of Q1. So that is the transaction. And the second very exciting feature that we introduced in 2.7.0 is topic level policy. So for people who have been using Pulsar for a while, is the Pulsar provide a very flexible policy mechanism for people to control how you want to configure your storage retention, rate limiting, resource usage per namespace. But those policy are configured per namespace. So it kind of brings some of the inflexibility to the user, because for user, sometimes they want to categorize their topics based on use cases, but within the same namespace, they want to have different retentions for different topic, or even they want to configure different rate limiting parameters for different topics. So there's no way for people to do that before 2.7.0. So it ended up causing a lot of people kind of rethink how they need to structure their tenant namespace and topic hierarchy. And a lot of people just push the topic to namespace. So you end up having a topic per namespace, which is not a great practice for people to use Pulsar. So to solve those problems, we introduced a mechanism called topic level policy. The topic level policy allows you to configure a policy for individual topic. And this is done through a mechanism called system topic. So we introduce a system topic for each namespace, and the system topic would be used for storing all the topic policy change events. And those change events represent a change made to a topic policy. And on the Pulsar broker side, the broker will read from this system topic and materialize the topic policy in the broker cache. So when you want to read and write the topic policy, it will become much easier. And using a system topic also provide a very good way for the administrator to audit all the changes that happen within a namespace. So it's a very kind of a great security features that we kind of bring in by using a system topic to allow people have the auditing capability. And so this is kind of brief introduction how we implement topic policy. And from the end user perspective, to enable topic level policy, it's also very easy. Like you need to enable two features. One is enable the system topic And so once you have the system topic enabled, then the topic policy would use system topic for storing all the topic policy change events. And once you have the system topic enabled, you can configure topic level policy enabled to be true. And after that, then you are good to use all the topic policies. And for the end user, for the administrator, the command to use topic policy is very similar as how you would use a namespace level policy. So in the namespace level policy, you usually use a command called pulsar-admin namespaces set a certain policy to specify that policy. And what you need to do is just change namespaces to topic, and then you can specify the policy for individual topic. In 2.7.0, we already implement almost all the policies that existed in namespace policy on topic policy, but there are still a few policy are missing in the topic level policy. So in the upcoming 2.7.1 and probably 2.8.8.0, we would complete all the policy to make it available in both namespace level and topic level. And just want to paint a big picture. We are also planning on adding a kind of tenant level policy. So you are able to configure the policy all the way from tenant namespace to topic. So then this will give different level of control. Like tenant can be like the system, the platform maintainer can just like configure tenant level policy, and when a team use the platform, they can create a namespace, and they are responsible for configure the namespace level policy. And when a project within that team want to use a topic, and the project itself can configure the topic level policy. So this hierarchical policy would provide a flexibility for different users in different team to be able to control how they want use Pulsar. So that is the top level policy. And the next big feature I was really excited about is the native ProBuff schema. So to give a little bit background in the schema part is all the existing struct schema store the schema information using Avro specification. So no matter that where you using Avro, JSON, or ProBuff, their schema information are converted back to the Avro specification. It works for most of the use cases, but there's some limitations coming out of this approach. Is it only works when like the JVM class loader can load classes that implement generate mastery v3. Generate mastery v3 is a base class from protobuf. And for some of there were some of the challenges were coming from Presto to process the messages that are encoding using protobuf. Because some of the JVM class loading doesn't work very well there. And the second problem is when we convert one type system, like for ProBuff, I would say ProBuff and Avro have their own type system. So when we use Avro specification to represent the schema of ProBuff struct, it kind of lose the some of the accurate type information during the conversion. So you are not you don't use the Avro schema to represent the accurate type information of ProBuff. So it causes some trouble when you want to integrate with data processing engines, because you have to find you need to let the data processing engine process the exactly type that is stored in PROBAF, and which the Avro schema doesn't do very well for PROBAF. And the last point is the PROBAF actually have a very wide support than Avro in terms of the language coverage. So in 2.7.0, we introduced a new schema called PROBAF native. And the PROBAF native schema is very similar as other schema, but it's a bit different. Is you have to provide message that it is generated from PROBAF, so then it can take the type information or schema information from that struct and store the information in a PROBAF description in the schema information. So you don't lose those kind of type information during the conversion. And when so after one of the benefits of introducing PROBAF native PROBAF schema is we are actually it's much easier for Presto, the Pulsar Presto connector, to query the existing PROBAF encoded messages, because we don't need to write additional schema handler to convert some of the messages, convert the data that is described in Avro and to kind of PROBAF, and we can just leverage the existing PROBAF encoder and decoder in Presto to query the PROBAF data there directly. So it brings a lot of great integration between Pulsar and data processing engines. So the next one is what we call resource limitation. Prior to 2.7.0, there's no way for people to control like how many tenants or how many namespace per tenant or how many topics per namespace that Pulsar cluster can give to individual user. So a lot of people end up implementing a broker interceptor to intercepting those RESTful API, and then put some resource limitation there to control like how many tenants and how many namespaces that a user can have. And in 2.7.0, we introduced that natively in Pulsar. So now you are able to kind of configure what is the max tenant that you want to give the entire user for a Pulsar cluster, and what would be the max namespace per tenant, max topics per namespace, and max subscription per topic. So in this way, you are able to provide a better control, like how people would use namespace and how people would use tenant. So this is the resource limitation. And those are kind of the kind of major features that introduced in 2.7.0, but definitely there's a lot of great enhancement, improvements in different areas. I would encourage you to kind of check out the Pulsar website and read the 2.7.0 release notes. It covers all the details that that we have like introduced in 2.7.0. And next, I want to share some of the upcoming features that would be either going into 2.7.1 or 2.8.0. So I'm listing out some of the major features here. Is the first thing is the the community has made a very great progress in PIP 45. That is introducing a pluggable metadata interface. And the motivation of introducing a pluggable metadata interface is we want to provide a great abstraction on the metadata storage, so people can use Zookeeper in the and or etcd or any other implementation. So the first goal, the first goal of P45 is providing a clear metadata interface. And the next step is we introduce an implementation based on etcd. So you are able to use, if you are already using etcd, you don't need to use Zookeeper. You can just use etcd as a metadata storage for Pulsar. And the third step is we will be introducing uh, implementation based on Bookkeeper to bootstrap the metadata storage itself. So this would totally animate the usage of Zookeeper, and it would simplify the installation and deployment of Pulsar. So that is P45, and I would say we are kind of 80% to 90% on completing the entire metadata interface there. The next major like items that would going out in 2.8 is PIP50. PIP50 introduced a package management service for function sync and sources. So right now is Pulsar try to store the packages of functions and things as blob in Bookkeeper, but it's not very convenient, because if you're writing your own function, and this function you want to run multiple instances on multiple different functions in Pulsar, you end up upload the same function package again when you update the when you create a new function instance or update the function. So the package management system it want to kind of simplify the workflow, so you can upload your a package of the function into Pulsar, and Pulsar is able to keep track all the versions of the packages. And when you want to use this package, you just create a function and reference that package. So you don't need to up that package again when you want to create multiple function instance. And it also provides the ability for people to discover like what are the functions available in this Pulsar cluster. So people don't, if there's already a function exists in the Pulsar cluster, they can just reuse that function. They don't need to upload the function again, and provide a very good, great way on tracking individual versions. So you are able to do those A/B testing between different functions, and you are able to roll back into previous functions, because every package is version is associated with a version. So it's expected to like release as 2.8, and we are welcome everyone to try it out and give us feedback. The next one is PIP75. It's probably not directly related to end user, but we have been using patched Google ProBuff generator on generating the code for the protocol, or the wire protocol between Pulsar client and Pulsar broker. That ProBuff generator was based on a very old version. I think it was ProBuff 2.4. And there's a lot of progress that was happening in ProBuff, and we are not able to take those changes back into our generator. So in PIP75, it introduced a very light ProBuff generator based on a newer ProBuff version, and that would bring in a lot of new features in the ProBuff, new enhancement in the ProBuff to improve the entire like wire protocol between Pulsar and Pulsar client and brokers. So it's a change in mostly happening internally within broker, but it might bring in some of the performance enhancement that can be observed in the end user side. The last one is on the streaming dispatcher. So that is newer feature that was introduced in the broker side, which is released as a developer preview. So to give a bit more colors about streaming dispatcher is in the Pulsar broker right now it try to read data from bookkeeper in batches. So like say the consumer asking for like 100 messages, it would issue a read 100 entries from the brokers, and the broker need to wait until all the 100 entries coming back before dispatching the data to the user. So in a catch up read case, you might be seeing some like throughput limitation coming from the how you want to configure what is the max batch entries you want to read from bookkeeper. So it's a batch read like situation, and for a lot of people, if you want to get a very high catch up read throughput, you have to tune that setting, and it's very difficult for people to get it correct. So instead of doing a batch read, we kind of extend the existing dispatcher to make it more become a streaming dispatcher. So you can read the entries from Bookie in a streaming way and dispatch the data immediately to the consumer. So you don't need to worry about like how I want to configure the batch size that I need to read from the Bookie. And everything will be handled by the broker. So the broker will control how fast it would read from the bookies and streamline all the response directly to the client. That is still a developer preview feature, and we hope that feature will be kind of productionized in one release after 2.8. So that is kind of the those are kind of the 4 major features that will be released in the upcoming 2.8. But besides that, I think on the tier storage side, we are also kind of making a huge enhancement in terms of how we managing offloading data to tier storage. Right now, the tier storage offloading is based on ledger. So each time when you roll over a ledger and you need to, it will trigger offload, and you offload the data ledger by ledger. And this would cause a problem is that if you roll over the ledger too frequent, then it will cause generating a lot of small files in your tier storage, which is not very efficient for a lot of batch processing workload. And if you configure the ledger rollover to be like rollover less frequently, then you will end up having a very large ledger to offload. And when offload comes in, you have to read this large ledger from Bookie back to broker, and broker right to tier storage. So there's a lot of issues exist in the existing tier storage offloader. So the motivation of PIP 76 is introducing a streaming offload. That means when a broker receive a message, after it successfully write the message to the bookies, the streaming offloader was streaming the data directly to the tier storage, and it brings in benefits in terms of how we want to control roll over the offload data versus roll over the data in bookkeeper. So you can configure the streaming offloader to roll over a bucket, also an object every certain size of the data. So this would help produce equal size of the object in your tier storage and also reduce the amount of the objects that would exist in the tier storage. And in general, it will improve the performance when you want to do batch processing over those offloaded objects. And I think all the features of this streaming offloaded is already implemented and probably already merged. And that is going to be released as part of 2.8. The last one is the Presto circle on the Pulsar side is that is related to the native probab schema. Is right now we write a lot of customer code in the Presto connector, so we implement its own schema handler, and which we need to kind of interpret individual like columns and struct to like the types that Presto can understand. But Presto already have a very great integration with Avro, JSON, Probab, those kind of popular formats. So PIP71 kind of changed a bit of the way how we do the integration between Presto and Pulsar. We switch from schema handle to Presto decoder, which means we don't need to rewrite. We need to write our own code to kind of interpret the data stored in Pulsar to the Presto types. We can just use existing Presto decoders to read those schema, read those data that are encoded in different type of the schemas. And the benefits coming out of that is you can always get the latest updates and as well the enhancements that Presto made in their decoders. So it would reduce the overhead for us to maintain the customization code and benefits a lot of users as well. And on the function side, there are kind of two major changes. Is the a lot of people running functions on Kubernetes, and they want to customize the state set that Pulsar schedule for running those function pods. But right now, the Kubernetes manifest customizer is only do that per function, which means if there are some common labels, common annotations you want to add to the function parts, you're not able to do that. You end up doing like function by function, which is now kind of a trivial solution for a heavy Pulsar function users. So in 2.7.0, sorry, in the latest Marters, we introduced the concept is that you are able to configure some of the default options that you want the Kubernetes manifest customizer to customize those Pulsar function parts. And that is still a working in progress work. And it's going to be released as part of 2.7.1 and 2.8.0. And the second one is a huge optimization on the built-in source and Flink connector. It reduced the kind of the startup time by animating a lot of redundant operations that Pulsar doesn't need when running a built-in source and Flink connector. And I think that most of the changes already merged, and that feature will be coming in 2.8 release. So that is the kind of the updates on the Pulsar side. And I would use the remaining time to talk about two major ecosystem components that we have around Pulsar. The one is the Pulsar Flink integration, and the last one is the Kafka on Pulsar. So we released a new Pulsar Flink connector based on Pulsar 2.7.0 and Flink 1.12. 1.12 is the latest Flink release. It includes a lot of great features like unified source API, unified table API, and like I think bring in Blink planner to be able to improve some of the batch processing that Flink support. So the 2.70 like Flink Pulsar Flink connector has a lot of additional features add on to the existing connector, which includes like a key share subscription support, exactly one thing, and upsert connector and new source and table API. And also the new connector is able to support the Pulsar topic that are stored data in primitive types, and which you can use a atomic Flink format to read those data. So I am going to kind of dive into kind of individual items. So key share subscription is a feature that was introduced in Pulsar 2.5. And the key share subscription is allow people increase the consumer parallelism to beyond the number of partitions. And so you can scale up your consumption and be able to also to be able to guarantee the ordering on reading individual keys. And it has been used in a lot of stateful processing, stateful streaming applications, but it hasn't been integrated with Flink. And in this 2.7.0 release, we integrate key share subscription into like the Pulsar Flink connector. And to enable this feature is very easy. So you can just configure a property in a connector called enable key hash range. So in that way, it would compute the key hash range based on the parallelism that your Flink job config for the source, and then this would allow you like use multiple key ranges that are larger and they are more than the number of partitions. And for people who want to learn a bit more details, that you can click these links to learn a bit more details about key share subscription and how we implement key share subscription in the Flink connector. The next big thing in the Flink connector is exactly one thing. So prior to 2.7.0 connector, Pulsar Flink connector already provide exactly one source connector and at least one thing connector. But in 2.7.0, we kind of complete the picture by introducing exactly one thing. What does that mean is now, when you use Pulsar and Flink together, you are able to create an exactly one Flink job by reading the data from Flink from Pulsar and process the data and write data to another Pulsar topic. You are able to achieve end-to-end exactly once. And the exactly one thing connector is implemented based on the Pulsar transaction. So we kind of mark it as a developer preview feature because Pulsar transaction is still in developer preview mode. And the implementation is very simple because Flink provide a concept called two-phase commit thing function. And we just need to implement all the steps that begin transaction, pre-commit, commit, abort, and when you fail, you need to recover to commit and abort. And for Pulsar, the existing implementation, which is based on Kafka, the Flink community have a Kafka-based like two-phase commit thing function, and it kind of bring a lot of hack solution there. It's not as clear as clean as Pulsar because Kafka transaction doesn't have a clear notion about transaction ID. Instead, all the Pulsar transaction use kind of associate all the operations together with a transaction ID, and you can have multiple transactions concurrently happening without like competing with each other. So that benefits us on implementing this exactly one thing. And in the beginning phase, we just need to start a transaction and get a transaction ID. In the pre-commit stage, that we need just persist the transaction as part of a Flink checkpoint. And then commit abort will become very easy, just a commit transaction and abort transaction. And recover, it's also recover and commit and recover and abort also become really easy. You just need read the transaction from a checkpoint and then do the commit or abort based on the transaction ID. And it's a preview version. If you want to try out the transaction features in Pulsar, and that this is another one you should try as well. Upsert. So the existing Pulsar connector treat Pulsar topic as a stream, but in a lot of use cases, people want to treat the stream as change log streams. And Upsert connector kind of provide the capability for people to kind of treat an existing Pulsar topic as a change log stream. And then when you write the Flink application, you are kind of processing change log streams. You are interpreting the messages with data as an upsert event into a table, and a message with empty value represent a delete on that key in a table. And similarly, on sync side is when you process when you write a Flink job to kind of process or update a table, and it will write the insert or update after data as a normal Pulsar messages into output topic, and it will write the deletion of a key as a Pulsar message with empty value, which indicating it's a tombstone for the key in the table. So by bringing in upsert connector allows you to simplify a lot when you want to write a Flink application that is doing data change capture. So this is the upsert connector, and the last one, the next one is in Flink 1.12, it introduced the new source and table API, which the new source API is consolidate all the existing unifies both batch and stream processing. So you just need to write one source connector, which can be used for both batch processing and stream processing. And one of the major changes in the Flink 2.7.0 connector is it rewrite the connector to base on the new source in table API. And it's able to leverage the unified batch in stream processing runtime from Flink. The last one is prior to 2.7.0, like if you're using a Flink circle to kind of query and process the messages coming out from Pulsar, you're only able to kind of read those message metadata, but you're not able to mutate those message metadata. In 2.7.0, we kind of introduce the feature. Flink introduced a feature allow you to map connector metadata into metadata column in the Flink table. So we leverage that feature to map the master metadata into metadata column in a table definition. So things like the topic, master ID, sequence ID, publish time, event time, those are the metadata associated with one master. Those now are available as a column in the Flink table. Most of the metadata column are read-only, but some of them are kind of writable. It aligned with the Pulsar concept. For example, you're able to write the messages to Pulsar like by specifying the event time. You're able to attach like certain properties into the Pulsar messages. So you're able to do it through like Flink circle into 2.70. Since it's a huge change, there's a lot of change happening in the Flink side and as well as in the Flink Connect side. So definitely there's some code you need to make when you migrate from an old connector to a newer connector. Like a lot of changes related to connector settings. We remove the connector prefixes and adjust a bit the Pulsar properties. Just want to show you an example is in the previous version, when you write a Flink circle, you need to create a table and you need to specify a lot of like parameters, and a lot of parameters will start with connector dot type, connector dot version, connector dot topic, which is not which takes a lot of time from the user. And so in the 2.70, it kind of remove a bunch of the settings to make the properties when you use to create a table become more clear. So you don't need to write a lot of duplicate code or settings in a circle query. And another thing here is when you want to specify the Pulsar client configurations, you have to specify in a very weird way is the connector.property.0. You need to specify the key value pairs. In the 2.70, it will become much easier. You just need use properties.Pulsar settings and the value. So this is the difference when you want to migrate from existing version to a newer version. There's some still working in progress items, like we mentioned there's a new source API introduced, and we want to take it further by integrating a unified batch in streaming connector. So some of the readers can read directly from tier storage or from bookkeeper, and some of the readers can read directly from broker. So it can accelerate the whole process for doing unified batch in stream processing. And one large of the efforts that we have spending recently is contributing the entire Pulsar connector to upstream Flink. And it includes like source sync, dynamic table, catalog, and as well as the new upstart Pulsar connectors. So if you like the Pulsar connector to be part of Flink, click this Jira issue and leave a comment there, and we're happy to accelerate the process there. We have been working closely with the Flink community to get this done before 1.13 release. Okay, I have only 3 minutes left. I want to kind of share a bit the progress on the Kafka and Pulsar side. And we have been making a very great progress in terms of the backward compatibility with different Kafka version, and more recent efforts on KOP is on productionized KOP in a very large scale. We have been working very closely with Tencent on migrating the existing Kafka workload to Pulsar using KOP. So some of the efforts here are kind of cooperation from between StreamNative and Tencent. The first one is we are introducing a continuous offset, because the previous implementation is kind of using a very hacky way on generating wrong offset by combining 3 different wrong numbers together. And quickly we found when we want to run KOP in a very large scale, like in Tencent production, it will quickly run out all the numbers there. And also it doesn't align with the Kafka existing semantic, because Kafka offset is increasing index. So in KOP, so in Pulsar, we introduced a concept called lightweight broker entry metadata to kind of store the offset or the index as part of the entry metadata. And KOP leveraged that feature to support continuous offset. The next one is about performance. We introduced an entry formatter to kind of animate the conversion between Kafka records in Pulsar messages. And now we are able to kind of make KOP close to the Pulsar performance. So it's really great performance. And another thing is right now KOP support all the versions, like all the way up to the Kafka 2.6. But there's one major missing piece is a Kafka transaction, and we are catching up, and we are almost there, and that would be released as part of like the upcoming 2.8 release. And Envoy is a part that is for exposing the Kafka service outside of Kubernetes. So we made a lot of progress in KOP, and we expect to have a GA release along with a Pulsar 2.8 release. And we also are going to make KOP available on StreamNative Cloud in Q1 2021. So if you're interested in using that feature, like follow us, and we'll keep everyone posted about the progress there. And that's all for today's TGIP. It takes a while for me to go through all the exciting things happening in the Pulsar community. And I just want to share that we are going to have more events around Pulsar. Every Wednesday on the third week, we will have a Pulsar office hour. And if you have any questions you want to discuss with Pulsar experts, feel free to join the Pulsar office hour. We would answer those questions for you. And every fourth Wednesday, we would have introduction to Pulsar 101. It's a free introduction, like training, and a free introduction webinar. And if you're interested about all the concept of Pulsar, feel free to join that webinar. It happens every like fourth Wednesday. And follow our Twitter, and you'll get notice about those events. And that's all. And thank you for everyone's joining the call. I'm not sure if there's any questions. If not, I will probably just say thank you. And if you have any questions, feel free to reach out to me, to my coworkers in Pulsar Stack channel, email. Thank you, everyone.